Let's talk what happens when I dilate a line today. All right, dilating a line. Because again, I know you guys think dilations, right? My figures get bigger or smaller, right? Figures get bigger or smaller, but hey, lines can't get bigger or smaller. So what happens with a line when I dilate it? All right, take a look at my first example. We're going to dilate it with a center at O and a scale factor of 2. So my first question, are points A and B going to get further away, or are they going to get closer to O? Scale factor of 2. Are A and B going to get further away or closer to 2? 2? Farther away. All right. And now look, we can't go up and over, so just eyeball this now. Ready? Eyeball it. Everyone sees how far away point A is, double that distance, and pretty much eyeball it. Estimate. Where's A prime going to be? Go ahead. Where's A prime going to be? Double that distance away from O to A. Put where you think A prime is going to be. Where do you think A prime is going to be? Again, should not be on the other side of O. Should be on the same side. Just double that distance. I'm just going to eyeball it, maybe right here, A prime. And do the same thing for B prime now. Double that distance away. And you don't need a straight edge. Go ahead and draw in that new line now. A prime, B prime. There you go. Can you tell me something about the two lines? Nice geometric term about these two lines. They're not the same line, right? But what can you tell me about the two lines? AB and A prime, B prime. After I just dilated them. They remain, what do they look like?
Parallel.
They're still parallel. So when you dilate, ready? When you dilate, lines remain parallel after a dilation. Lines remain parallel after a dilation. All right, I'm going to change it up on you now for the second example. Notice where point O is now, my center of dilation. Notice it's on the line now. How is that going to be different than what we just did here? All right, still a scale factor of 2, so the points are getting further away. Everyone see how far away A is from O? Go ahead, double that distance. Where's A prime going to be? Mark where you guys think A prime is going to be. Not on the other side, remember, not on the other side. Same side of O. Where'd you guys put A prime? Where's A prime going to be? Between O and B. They don't flip. That's what they don't flip. Okay. Right now, this has a certain distance. I want you to double that distance. So A prime should be somewhere, maybe up here. But look where it is. Isn't it on the line? It shouldn't go off the line. It should remain right on the line. And then go ahead, put point B somewhere. Put point B prime somewhere now. O and B have a certain distance. Double that distance. B prime's probably going to be somewhere down here, but it's going to be somewhere on the line. So what am I trying to get at here? If your center of dilation is on the line you're dilating, the line stays the same. Okay, so here you go. If center of dilation is on the line, the center of dilation is on the line, the image is the same as the pre-image. So we have to just be careful today. Hey, when I dilate a line, where's that center of dilation? If it's on, the line remains unchanged, all right? Everyone all right between the two here before we get going with some reps? So if it's off the line, they're still going to be parallel, but if it's on the line, no change. Line stays the same. All right, take a look at one. Let's do this. We're going to take 3x plus 4y equals 20. We're going to dilate it by 1/3. So in your mind right now, points getting closer or further away? 1/3, closer or further away? 5, closer or further away? Closer. 2, 4, 2. That's my center of dilation. 4, 2. Okay, and there's my center of dilation. So we're going to take, here you go, we're going to take 3x plus 4y. We're going to take its points and move it closer to 4, 2. I'd like to see what this line looks like on the graph before we dilate it, though. Can you guys help me get it into y equals form so I can do a quick graph and see where it looks like before I dilate it? 3x plus 4y equals 20. Want to help me put it into y equals form so I can graph it? 6, first step. Subtract 3x over. Good. I get 4y equals negative 3x plus 20. Next step, one more step to get into y equals form. 1.
Divide by 4.
Everyone good? Divide by 4 now. So it looks like I get negative 3/4 x plus 5 when I divide 20 and 4. All right, real quick, let's graph this y-intercept so I can graph it. You can also use your graphing calculator, but I don't want to take the time to get that out. And what's my y-intercept up here? 12, y-intercept?
Positive 5.
+5. So everyone go to 5 on the y-axis. 1, 2, 3, 4, 5. Boom, there's 1 point. And now use your slope to get a couple other points. So what's the slope of this line? 5's the y-intercept slope. 13?
Down 3/4.
Negative 3/4. So down 3, right 4. Perfect. 1, 2, 3. 1, 2, 3, 4. 1, 2, 3. 1, 2, 3, 4. Nice, nice, nice. Again, straight edge not really needed. I just want to see what this line looks like. There it is. All right, you ready to dilate it? We said 1/3, they all get closer, and it's around 4, 2. Everyone locate where 4, 2 is, please. And where's 4, 2? 2, where's 4, 2, Nate?
One of the points.
Hey, look, 1, 2, 3, 4, up 2. There it is. It's already on the line. And what did we just say? If the center of dilation is already on the line, what do we know about the new line then? 1. Anna, what do we know about the new line? Guys, I don't care if the scale factor is 1/3, 2, or 200. The line's going to remain the same if your center of dilation's on the line. Because all these points now are going to get closer, sure, but they're still going to be on the line. They're all going to get closer, great, but they're still going to form the same line. So my new line, what am I calling here? The image line N, it's going to be the same equation. You can stick with the original, 3x plus 4y equals 20. You can do the one we just had here, negative 3/4 x plus 5. They're both the same line. Is everyone seeing that, though? If the center of dilation is on the line, equation's not going to change. Same exact line after I dilate it. Questions? All right, let's go. All right, so I have 3 halves x minus 4. We're going to dilate it by 3/4, centered at the origin now. So all our points are getting closer to the origin, 3/4. All right, first point you can graph. What's the y-intercept of this line so I can get a look at the graph? 13, y-intercept. Okay, everyone, 1, 2, 3. Here you go. Here's my first point. And let's graph a couple other points using your slope. What's the slope of this line? 6, slope. 3/2. Up 3, 1, 2, 3, right 2. Up 1, 2, 3, over 2. There it is. And what's the center of dilation here again? What's for this problem? Center of dilation. What are we looking at? 4? Origin. Hey, everyone, look at your line. Is the origin on your line? It is? No, it's not on the line. So that means it's not going to remain the same line. So we can automatically get rid of choice 3. It's not staying the same line because the origin's not on there. All right, so how do I find the equation of the new line? Go back to the very beginning of our notes today. If I dilate around a point that's not on the line, we still know what? These two lines will still be what to each other? 11? Parallel to each other. So go back to my choices. You guys said 3 halves was the slope, so I should still have a slope of 3 halves. Right? Parallel lines have the same slope. So at least I know the slope's got to be 3 halves. And I get it by process of elimination. It's going to be 4. But what if I had to come up with that equation on my own? Everyone's clear that they're going to remain parallel, so that's why my slope remains 3 halves. How do I find the new y-intercept? Go back to what we worked on Wednesday and Thursday. This point right here is 0, -4. And it's around the origin. What's the trick we can do with the scale factor and the point if it's around the origin? How can I find my new point? What did we do quickly with the point and the scale factor if it's around the origin? What can I do with the two? Do we remember what can I do? I know we talked about it. Quick, I can multiply. So ready? 0 times 3/4 is 0. 3/4 times -4. If you do that in your calculator, that'll be -3. So that's where that point goes. All right? So that's how I know it's going to be -3 for my y-intercept. Remember, I can just multiply. Any questions from you guys yet? I think I'm going to do one more with you and then see what you can do on your own for that next one. All right, line MN, dilated, scale factor of 2, centered at 0,6. Heads up, 0,6, not the origin, 0,6. MN has this equation, y equals -3x plus 6. What's the equation of the new line now? And I'm dilating around 0,6. And I didn't give you a graph here because I wanted you to think about it a little differently. All right, I didn't give you a graph here. Look at where I'm dilating around again, 0,6. Y equals -3x plus 6. Will 0,6 be on here? If I did have you graph this point, do you think 0,6 would be on -3x plus 6? What's the y-intercept? What's the y-intercept up here? 10. What's my y-intercept? 6. So it's good. 0,6 is a point because it's the y-intercept. Look. 1, 2, 3, 4, 5, 6. That would be the first point you graph. That's 0,6. So it's going to be on the line. So what do I know about my new line then? If my center of dilation is already on the line, what happens to the new line? 10 again? Stays the same. Done. All right. Points on there, stays the same. All right, I need you guys to try one out on your own here. So go ahead with Aaliyah here, number 4. She's going to dilate that line by 2. There's your center of dilation, 3, 4. And she's like, I think my new line's going to be negative 4/3 x plus 6. Correct or not incorrect? Plus 16. So graph, get it in y equals form, graph it, see where 3, 4 is, and then we'll make a determination if she's right or wrong. What are you noticing? When you graph the original line, isn't 3, 4 already on there? So is she correct by saying it's going to be plus 16? No, incorrect, because it should stay the same line, negative 4/3 x plus 8. So incorrect. The new line remains the same as the old line. And one more, this has nothing to do with dilating lines. Well, I guess it does, but not what we talked about today. So I have this line segment AB. You guys see what A and B are. Can you determine how long its image is if I dilate it by 1/2? So I'm going to take AB, dilate it by 1/2, so it's going to get smaller or bigger? Smaller. What's the length of the new line now? New line segment. What's the length of the new line segment? All I'm going to give you is this. Here you go. Distance. You're going to need distance formula because you're finding the length of a segment. Sometimes I need you guys to think on your own here. If you want to talk with other people within your group, that's fine too. But I know how this class rolls. Because there's a couple ways to get to the final result here. And I just don't want to say, let's do it like this and that's it. I want you to think about this. It's centered at the origin, which is good. It's not going to remain the same line because you're dilating by 1/2 now. It's not the same line, sorry. And it's a line segment, remember, so it doesn't go on forever. So you guys figure out how you want to find the length of A prime, B prime. Because there's 2 different ways you could do it here. So think about how you could find the length of A prime, B prime. You got the coordinates of A and B. AB has a certain length. And now you're going to dilate it by 1/2 at the origin. We'll talk about the different methods here at the end. Okay, let's talk two different ways here. Two different ways. First way, you could have found the distance of AB. Use distance formula. Found the distance of AB, and I believe that distance should have been square root of 25 or 5, length of 5. And then since it's being cut in half, A prime, B prime would have been half of that, or 2.5. So A prime, B prime had a length of 2.5. Or, all right, I figured most of you may have done it this way. Find A prime, B prime by multiplying both coordinates by a half. Why am I allowed to multiply? Centered at the origin, I can do that, multiply them. So A prime would have been 1, 1.5. B prime would have been 2.5, negative 0.5. Plug it into the distance formula, your x and y's. A prime, B prime would have been, what did I get? I didn't even take the square root there. 2.5 again. Okay, so either way, dilate the points, find the distance, multiply by a half. All right? Questions? Okay, I'm probably pretty confident you're going to get through all these multiple choices. Chromebook immediately out after. Make sure you got them correct. Tomorrow we start reviewing. All right, we got a test coming up Wednesday. Start reviewing.